Today, we're tackling an important concept in object-oriented programming, dependency injection. By the end of this video, you'll have a solid understanding, and we'll even walk through a practical Java example. All right, let's start with the basics. So, what exactly is dependency injection? Dependency injection is a design pattern where objects receive their dependencies from external sources rather than creating them themselves. Instead of hard-coding dependencies inside a class, you provide these dependencies to the class from the outside. This makes the code more flexible, reusable, and easier to test. In fact, dependency injection is a cornerstone of modern frameworks like Spring and Java. Let's visualize this with a quick example. Imagine you have a class called car, and it depends on an engine object. Traditionally, without dependency injection, the car class might look something like this. As you can see, the car class is responsible for creating an instance of engine. The problem here is that car is tightly coupled to engine. If we want to swap out engine for a different type of engine, say an electric engine, we'd have to modify the car class directly. This is where dependency injection comes into play. Instead of creating the engine inside car, we'll inject it into the car class from the outside. Let's rewrite this example using dependency injection. Here's the difference. Instead of car creating its own engine, we now pass an engine object to the car class when we create it. The car class doesn't care where the engine comes from, it just needs an engine to work. Now that we've injected our dependency, let's talk about why this is awesome. Dependency injection brings a lot of benefits. Loose coupling. First, it decouples the classes so the car no longer depends on a specific engine. We could swap out the engine with any class that implements the same methods, like electric engine. Easier testing. Using dependency injection, testing becomes easier. You can pass a mock or a fake object instead of using the real engine when unit testing. Flexibility and reusability. Dependency injection also increases flexibility and code reuse. If you want to use the car class with different types of engines, gas, electric, or even a mock for testing, you can easily do so without modifying the car class. Let's expand this example to include an electric engine and demonstrate how easily we can swap out dependencies. Now, without changing the car class, we've swapped in an electric engine. This is the power of dependency injection, making your code flexible and adaptable. Dependency injection can be implemented in several ways, and there are three main types. Constructor injection. As we've seen, this involves passing dependencies through the constructor. Setter injection. Here, dependencies are provided through setter methods after the object is created. Interface injection. This is more advanced and less common in Java, where the dependency is injected via an interface method. Manually injecting dependencies is great for small projects, but in large applications, it can get tricky. That's where frameworks like Spring come into play. Spring provides a robust solution for dependency injection through its inversion of control container, automatically managing object creation and dependency injection for you. So, that's the power of dependency injection in Java. It helps you write clean, flexible, and testable code. If you enjoyed this breakdown and want to see more in-depth videos on Java or software design patterns, be sure to hit the like button and subscribe to the channel. Let me know in the comments if you have any questions or if there's another topic you'd like us to cover. Thanks for watching, and I'll see you in the next one.